graphs and describing distributions. Data can be displayed using graphs, and there are several types of graphs to choose from. Some of the most common graphs used in statistics are bar graphs, pie charts, dot plots, histograms, stem and leaf plots, box plots, cumulative frequency plots. So how do we create these different graphs, and what type of graph would be best for our data? We'll begin by looking at an example. Height measurements for a group of people were taken. The results are recorded below in inches. We'll use this data to create several different types of graphs. We can create graphs by hand, using a graphing calculator, using a program such as RStudio or Excel. We're going to do these by hand. Before we begin, it's best to sort your data list. A dot plot is made simply by putting dots above the values listed on the number line. So to create our dot plot, we're going to make a number line. And on this number line, we'll label our values. Our smallest value is 58, and our largest is 73. We have one value that's 58, one that's 59, one that's 60, one that's 62, 4 that are 63, one value that's 64, a 65, 2 values that are 66, a 67, 3 68s, 69, a 70, 2 71s, and a 73. A stem and leaf plot. In a stem and leaf plot, the data is arranged by values, and we use the digits in the largest place as our stems, and in the smallest place, those are our leaves. The leaves are displayed to the right of the stem. We can create split stem plots when we have a lot of data that divides up the stems into small equal groups. Back-to-back stem plots can be used when comparing two sets of data. Let's create a stem and leaf plot for our data. Here's a copy of the values that we're working with. Now with the stem and leaf plot, we decide on our stems and our leaves. Since all of these are 2-digit values, my stems will be the tens digit, and the leaves will be the ones digit for each number. On the stem and leaf, we put the tens digit, these would be our stems, over here to the left of the line, and over here would be our leaves. So we have a 58 and a 59. We have a 60, 62, 4 63s, a 64, 65, 66, 2 of those, 7, 3 68s, and a 69. We have a 70, 2 71s, and a 73. As you can see, our stem and leaf is quite heavy in the 60s department. So what we can do is we can create what's called a split stem plot. Now with our split stem plot, instead of just having our stems be the 10s by themselves, we'll group them into 2 sets of 10s. So we'll have 50 through 54 and 55 through 59, 60 through 64, 65 through 69, and same with the 70s. So we'd have nothing beyond our first 5. The 8 and the 9 would go there for 58 and 59. 60, 62, all of our 63s. 64, and then down here would be the 65, our 2 66s, 67, 3 68s, and the 69, and then we'd have the 70, 71s, and 73. You can see a little more shape to our graph when we create a split stem plot with this data. Histograms are created by dividing the data into equal classes or bins. We'll count the number of observations within each class. The horizontal axis will represent our variable values, and the vertical axis will represent our frequencies or relative frequencies for our data. Now, if you use a program such as Excel or RStudio to create your histogram, it'll have default bin widths. The size of your bins is really dependent on how many pieces of data you have. Again, here's our data. Now there is no right or wrong bin width to choose. However, we want to make sure that our bins are not too small or too large for our data. We have 21 pieces of data here, and they range from 58 to 73. So our range is 15. I'm going to choose 4 for the width of each bin. To keep it even, I'm going to start with 56 to 59, and then 60 through 63, 64 through 67, 68, through 71, and 72 through 75. Now I'm going to go through my list and look at the frequency of numbers within each bin. I have 2 in this bin, 1, 2, 3, 4, 5, 6 in the next bin, 1, 2, 3, 4, 5 in the next. Between 68 and 71, I have 7, and 72 to 75, I have 1. Now, of course, these could be reordered. I could start at 58 and do different widths for bins. It's up to you how to set up the bins. And again, if you use a program such as Excel or RStudio, it has default bins to use. So across the bottom we're going to label our bins, and going up the sides we'll do our frequencies. So for our first bin, the frequency was 2, so we're going to create a rectangle. And then we go up to 6. And in a histogram, our boxes or rectangles are side by side. And 5 for the next class. 7 for the next, and last just 1 here. Box plots not only help us identify features about our data quickly, such as spread and location of center, but they can also be very helpful when we're comparing data sets. Side-by-side box plots will be used for that. When we're creating a box plot, we first need to order our values in the data set in ascending order, in other words, least to greatest. We'll find and label our median, our Q1, our Q3, and our minimum and maximum values. In other words, we need to find our 5-number summary. We'll draw and label the scale on an axis, and it can be a horizontal or vertical axis. We will plot our 5-number summary and create a box that goes from Q1 to Q3. The height of the box does not matter. We'll create a segment within that box to represent the place of the median. We'll connect the minimum and maximum to the box with line segments. And if we have any outliers, we can display those using a box and whiskers plot instead of a regular box plot. In a box and whiskers plot, the outliers are displayed with dots above the values instead of line segments that connect. For the data that we've been using, here is the 5-number summary. So this is our min and max, Q1, our median, and Q3. So let's create a box plot for this data. First we need an axis, and I'm going to create a horizontal axis. And I'm going to put my 5-number summary on here. We're going to create a box that goes from Q1 to Q3. Then we'll draw a line to represent the median. Now note, your median does not necessarily split this box in half. In fact, the placement of this median in the box can help tell us a lot about our graph. Now we're going to connect out to our max and our min. So one thing to notice on this is that we have a longer tail towards our minimum than we do towards our maximum value. A cumulative frequency plot of our percentages, also called an ogive, can be used to view the total number of events that occurred up to a certain value. Let's create the cumulative frequency plot for our data. Now with a cumulative frequency plot, we need to organize our data and figure out the frequency of our values. So I'm going to make a chart over here for our values, their frequencies, and the cumulative frequency for each. So we start off with 58. It has a frequency of 1, so of course its cumulative is the same. 59 has a frequency of 1, so the cumulative frequency so far is 1 plus 1, which is 2. There's only one value, 60, so that's 1 plus 2, which is 3 for its cumulative frequency. 62. Now 63 has a frequency of 4, so we're going to add 4 to our previous cumulative frequency, and that puts us up at 8. Let's continue for the other values. Now we're going to plot. Our values will go along our horizontal, and the cumulative frequencies will go along the vertical axis. So I've labeled my graphs. Now I'm going to plot. At 58 we have a 1. At 59 we're at 2. At 60 we're at 3. 62 we're at 4. 63 we're going to jump up to 8. 64 is 9. 65 is 10. 66 puts us at 12. 13 for 67. 68 all the way to 16. 69 is 17. Then 18 for 70. 71 is at 20, and 73 will be at 21. And then we just connect our dots. Now another way to display our cumulative frequency is using cumulative relative frequencies, and that's getting the percentage for each. And it'll work out so that our last value is 100%. Since we have 21 data pieces, for our cumulative relative frequency, we're going to divide each value by 21 and multiply by 100%. So for these, for 58, our cumulative relative frequency is 4.76%. For 2, we're at 9.52%. For 3, when I divide by 21 and multiply by 100, I have 14.29%. 19.05% for 62. Then we have 38.10% for the relative frequency for 63. 64, we're at the 42.86. 65, we're at 47.62. Again, we're taking our cumulative frequency, dividing by our total, and multiplying by 100%. 57.14 for our percentage at 66. 61.90 for 67. 68 is at 76.19. Then 80.95%. 85.71% for 70. 95.24%, and last, our very last value should be at 100%. Our plot would be the same for a cumulative frequency plot, however, for cumulative relative frequency, however, our highest value would be at 100%, and we'd relabel our axis according to the percents, but the graph looks the same. It gives us a different way to read our data. We can also see when looking at a cumulative relative frequency about where our median would be. Notice where the 47 to 57%, so we know it's somewhere between the 65 and 66. Now to create our bar graph and pie chart, now, bar graphs and pie charts are best used with categorical data. So for our next example, we've got some categorical data. We have education level and number of students. Using this data, we'll create a bar graph and then a pie chart. A bar graph is created by listing the categorical data along the x-axis, and then the frequencies will be listed along our y-axis. Bars are drawn above each data value. So let's create a bar graph for our data. So here's our data up in the upper right-hand corner. I'm going to draw a horizontal axis and label it with our education levels. Now I'm going to create a y-axis, and it will be used for our frequencies. Our highest frequency here is 15. So for high school diploma, some college has a height of 6. Associate's degree has a height of 12. Bachelor's degree is at 15. Master's at 8. And doctorate at 2. A pie chart is a circular chart divided into sectors indicating the proportion of each data value compared to the entire set of values. Pie charts are very good for organizing categorical data. So here is our data set again, but now we need to get percentages for our pies. So there's 45 values total. I'm going to divide each number by 45 and multiply by 100%. So for our high school diploma, that's going to make up 4.4%. Our some college with no degree is 13.3%. Associate's degree will be 26.67%. Let's make it 26.7%. Bachelor's degree will be 33.3%. Master's is 17.8%. And the doctorate degree is 4.4%. So we're going to draw a circle. And we're going to divide this circle up into slices. And we can color the slices if we want to. We need to label them. We can label them by the colors or however we want. So first of all, the one that's closest to something I can do is the associate's degree is about 25%. So I'm going to create a quarter of a circle for that. And it's just a little bit more than a quarter of a circle for that 26.7%. Okay, so this is our associate's degree slice. Our bachelor's degree will make up about a third of the circle. Then the some college and master's degree are pretty close to the same size. However, the master's degree is slightly bigger. And then our remaining slice will be cut in half for our two little 4%ers. And let's label these. Using a program like RStudio or Excel, will make a much prettier graph, and we'll have colors in it and everything. Now we're also concerned with the patterns and shapes of graphs that represent our data. What we will look for is uniformity. Is our graph roughly the same all the way across? Symmetry. We have data that's symmetric about our median. Bimodal. Do we have a graph that shows more than one mode? Bell-shaped. Skewed to the right, where we have a lot of our data being on the left-hand side, but some large values that are pulling it to the right. We have a tail drag to the right side of our data. Or skewed left, where we have a tail of data sent to the left-hand side of our graph. All of these are very important traits that we need to watch for when we describe graphs of data.